Well, hello and welcome back to EngX Community Day 2023. I'm Sergey Konstantinov, and I'm thrilled to welcome you to our online event, Sustainable Green Software Development. As the world grapples with challenging and urgent issues of climate change, it's essential for us to recognize the various sectors, including software development, that tackle the crisis and contribute to a sustainable, low-carbon future. And before we begin, just a little reminder that the session is being recorded, and the recording will be available approximately in a week or in 7 days. So if you have any questions during the session, please drop them onto the agenda page. And now it is my pleasure to introduce our speaker, Chris Howard, whose interest is sustainability and open source technology led him to engage and collaborate with the Green Software Foundation. So, Chris, whenever I write my script, I use VS Code and it highlights my code green. Does it always mean that it complies with the Green Software Foundation?
No, unfortunately not. And great to see you say here as well. No, unfortunately, it doesn't necessarily mean it complies. But hopefully, after today's session, there'll be lots of interesting learning points that people will know to help their code be a little bit more compliant.
Okay. Thank you. So we're all ears, so the mic and floor is all yours. Share your knowledge.
Excellent. Well, thank you so much. And great to be joining you wherever you are in the world. I'm just going to share my screen and we'll kick off. Excellent. Here we go. So my name is Chris Howard. I'm the open source lead at EPAM Systems. But I also, as Hayes very kindly just mentioned, have quite a keen interest and look after our organizational membership of the Green Software Foundation. And today I'm going to be talking around that topic of sustainability, the ongoing climate challenge, and some of the principles and patterns that we can start to think about as we build and design kind of green software moving forward. So I think it's only fair to give you a little bit of context around the Green Software Foundation, and hopefully you can see on the screen. And a little side note here, my slides are quite kind of text simple. I try and talk as much as I can and give you a few kind of key highlights on the slides as we go through. So please do keep focused on those, but I promise there won't be too much to read, and there will be some visuals as well. So the Green Software Foundation, well, it has a mission, as you can see there, to build a trusted ecosystem of people like myself, like yourself, listening all over the world, standards, toolings, and best practices for creating and building green software. And don't worry, I'm going to explain what we mean when we talk about green software very, very shortly. But it also has a vision, and I think this is probably more exciting, around changing the culture of building software across the technology industry. This is about performance, security, cost, accessibility, but making sustainability a core priority of that software development. So perhaps 5-10 years ago, when we were talking about software development, we were maybe getting excited about the kind of agile ways of working, or even diversity and inclusion, which was a little bit of a hot topic. Now sustainability is really being embedded into that. And the Green Software Foundation are real champions, with some of the world's biggest organizations coming together to collaborate. If you want to check them out, it's greensoftware.foundation, and I'll be referencing them throughout this presentation. A lot of the material is also open source and Creative Commons, so some visuals you'll see are taken from the Green Software Foundation. So, defining green software. Some of you are probably thinking, gosh, what is this? Let's get into the detail. Well, hopefully I can do a good job of explaining it now and you'll get a view, and we'll keep referencing back to these key titles on this slide throughout the entire session today. But really, building green software and applying these green software principles to your software engineering does go far beyond the technical aspects and brings in things like organizational change, development, and culture. But we won't be talking about that necessarily within the scope of today. Just today, we're going to be focusing on the development aspects. And you can see we've got green software as an application that emits less carbon. That's the key part here, less carbon. This is not about removing carbon. It's not possible. And as we go through today, hopefully you'll get a benefit of that. You're never going to get a zero piece of green software. That's not going to happen. It's about emitting less. And how can we do that? What practices, principles, ways of working can we use? And what even changes to your code can you leverage to make that possible? And there are two key things that drive green software, or give it its kind of body, if you like. One is that it's carbon efficient. So this is about changing the architecture of the application to be responsible for emitting less carbon. And it's also carbon aware. And this is the area I get very excited about. And there's a big section on carbon awareness later, about changing the physical behavior of the application to understand how it's working and where it's working and when it's working, to be aware of the carbon that's in use, if you like. And under that idea of carbon efficiency, we have energy efficiency and hardware efficiency, two very important areas as well. Hopefully more exciting than checking the battery on your laptop. So we'll go into a little bit more detail around what those mean. But all of that comes together to build applications, solutions, software that are green, and we call that green software. So let's take a look, if you like, at the as is, like where are we today in the world? Well, why are we even talking about this? Well, by 2040, the global ICT sector, so this is information communications technology, and that's important to bring telephones and devices, etc., into the conversation, is expected to account for 14% of the world's carbon footprint, which is crazy figures. And most of that is coming from smartphones or smart devices and the data centers that facilitate that run those. And that means that actually this sector is on the trajectory to become really the most damaging. And I use that word lightly because I think that's a whole separate conversation, but the most damaging, or the potential to damage environmentally. And that's a strong figure. But similarly, if we then drill down a little bit into that data center conversation, data centers are consuming about 2% of the world's entire global energy, and they emit 3% of the world's greenhouse gases. And greenhouse gases, of course, we know are the damaging gases that exist in the atmosphere, that trap the heat and are leading to things like global warming. They're not the entire defining thing, but there are other factors that come into that. And there's plenty of resources out there for you that are interested in that conversation. What that interestingly does, though, is puts the data center industry on par with the airline industry in terms of those emissions. And perhaps that's a surprising factor to some of you. But how does this then ring true for a developer-centric view? Well, it's estimated by some official kind of journals and theories that there are about 27 million software developers worldwide. And by 2030, we're expecting that to hit 45 million. These are professional software developers. So that's an awful lot of people writing software and contributing to that carbon, but most importantly and most excitingly, having the potential to actually help mitigate some of those challenges and build and develop greener software. The United States is the largest, 4.3 million software developers at the moment. But GitHub, interestingly, and that's the open source world that I live in, actually looks at all contributors. So not just professional developers, we're talking about students, we're talking about interns, part-timers, people doing it for fun. They actually think there's about 75 million software developers at the moment. So that number is much, much higher if you start to think about all of the people that are involved in this space. Apologies, we just jumped forward a slide. And this is really where you all come in as kind of being able to play a part in this. So what does this mean for the software you're building? Well, I think that's where we jump into my next thing, which is the role of green software development. Software really is key, pivotal, and center to this conversation. And how can you, the software you're building, be a part of that climate solution? Because we genuinely believe, and what you're going to see today will demonstrate that you can be a part of that. Well, the first thing is that, as the first point you can see on the screen, is that software is the key enabler in that efficiency. And an inefficient software on the greenest device just doesn't make sense. So you can build the world's best hardware, the greenest hardware, if you like, and we'll touch a little bit on that. But if you then build a super inefficient piece of software, and I'll explain how that inefficiency comes to fruition later, then it doesn't really make sense. Secondly, is that while the hardware consumes the energy, it's ultimately the software that triggers the consumption. So me opening Facebook on my mobile device, or me checking my emails, or sending a message on Teams, or even listening in today, that's the trigger for the consumption of the energy. Every activity that we're involved in is software or an app or a solution kicking off that kind of carbon consumption. And finally, most importantly, we just saw those numbers on the previous slide. tech adoption isn't going to stop or slow down or even decline. So there's no point of saying this is going to change in the next 5-10 years. It's an upwards trajectory. No one's going to be able to stop that global trend. So addressing these challenges through software is definitely going to be part of that solution. So it is really about making our software, our solutions, our architects, our designs, whatever it happens to be, as green as possible. And this relationship relies upon the software we build using less energy. And unfortunately, it's not that simple. This is not about us turning off our laptop at the end of the day, whatever it happens to be. And also, and maybe there's some of you in the hardware and infrastructure space, hardware doesn't escape either. So the software we're building should be built and made in such a way that it perhaps should be able to use old hardware, get rid of this idea of hardware kind of obsolescence, make that less of a problem. And we're going to talk a little bit about embodied carbon later on as well, and how carbon's involved in the manufacture of devices and how that's used across the lifetime of device. So as you can see, really, everything we're talking about goes back to that key tagline around carbon and carbon emissions and reducing it. It's all about reduction. And if we remind ourselves of that diagram, an application that emits less carbon, this is what we're going to be talking about. So how do then in these various steps, these kind of building blocks of green software, we're now going to jump into each of these and talk about them in a little bit more detail. And we call those the kind of green software principles. And I'm going to focus on 3 of them today, 3 that I think give the real kind of body to this conversation and also make sense to yourselves all over the world listening around engineering, business analysts, testers, QAs, architects, even perhaps some of you going through your own training in this space. These are 3 items that are going to jump out to you and actually be relevant to kind of engineering and the world that we're talking about from a software development perspective. So the 3 are kind of energy efficiency, carbon awareness, and hardware efficiency. And as we know, green software is carbon efficient software, meaning it emits less carbon. So only these 3 activities reduce carbon emissions of software. So we have energy efficiency. This is using the least amount of electricity possible. We have carbon awareness, doing more when electricity is clean and less when it's dirty. And we're going to explain that in a little bit more detail. And then hardware efficiency, this idea of embodied carbon. And they're the 3 things that we're going to drill into today. But I told a little lie. There is one important kind of foundation stone. And I am going to do a slide on it now, which is what we call carbon efficiency. So it doesn't directly reduce carbon emissions of a software, but it's important to understand where this green journey comes from. And we call this carbon efficiency. This is minimizing the amount of carbon emitted per unit of work. So that could be a task, a job, a process, a cron job, whatever it happens to be, so as to extract the most value as possible from that carbon. So it's important that all activities will always emit carbon, but we want to ensure that for every single gram of carbon that we emit into the atmosphere, we extract or we maximize the most value as possible. And being carbon efficient is about maximizing that value as much as we can. So in the software space, the part that we play in that climate solution is about building carbon efficient applications. And being carbon efficient is about building applications that add the same value for you and your users, but emit less carbon. So this is what carbon efficiency talks about. And once you've understood this idea that carbon emission is inevitable, we're not going to stop that. Carbon emissions are inevitable in this space. We can then move into our 3 areas, which are energy efficiency, hardware efficiency, and carbon awareness. So I hope you're still with me. We're going to jump into the 3 of them now. You've understood the idea of carbon efficiency, emitting the least amount of carbon possible, but maximizing value. Well, how do we do that? So let's jump in. Well, the first one is energy efficiency. And this is not, as I said at the beginning, about a little green light saying switch off this, etc. This is about real meaty stuff that we can start to be thinking about when we're building and designing software. All software, from the applications on your mobile phone that I just mentioned, through to training some of the world's largest kind of machine learning or LLM models running in massive data centers, consuming electricity, all require electricity. And one of the best ways to reduce electricity consumption and the carbon emissions through software is to just simply make the applications more energy efficient themselves. And that's our first principle. So it's our
Excuse me, we're experiencing some sound problem, and I think we will check them and fix them real quick.
Hello.
Oh, there you go.
Yeah, I was muted for some reason.
Okay.
Hi. Apologies. So I was saying many of us get to the point where we perhaps don't see electricity as dirty. We kind of have this idea that electricity is clean. When we plug our laptop in or we jump in our car, when we plug our laptop in, we don't have dirty hands. But when we jump in our car and see the exhaust and the fumes coming out of the back, then perhaps we have a different conception here of what electricity means. But we can always draw a direct line from the source of that carbon through to the device at the end of the journey. And that's why we state that carbon can be considered or is considered a proxy for electricity and vice versa. But nicely and importantly, there are low carbon sources of energy. So we have clean energy, which doesn't produce carbon emissions. So that's nuclear, for example. We have green energy. So this is this is sources of energy. And then we have renewable energy, which is things like wind and solar. So there are lower carbon sources of energy that we can leverage all the way up to kind of the oils and the coals, etc., which are the high carbon intense. And each of these emit different levels. And this is important when we talk about carbon awareness in the next section. But for now, having this knowledge about the use of energy can help us to think about how we can make changes in our code to start to leverage that. So this is the idea around energy proportionality. And this was actually kind of ideated by Google engineers. So in 2007, Google engineers came up with this idea of energy proportionality, which is there's going to be lots of these exciting terms as we go through, and I can promise there's some even crazier ones later on. But this idea of energy proportionality is the relationship between power consumed by a computer and the rate at which the useful work is done, so the jobs we were talking about. For us, let's just call it utilization. It makes a lot more sense. And this is a bit important for us because as engineers, as analysts, as testers, the more we utilize a computer or a solution, the more efficient it becomes at converting electricity to kind of practical computing operations. So when we're designing these solutions, we need to be thinking about utilization. So to improve efficiency, for example, would be to run workloads on as fewer servers as possible, but have those servers running at the highest utilization rate, maximizing the energy efficiency there. And this often isn't the case. We know many of you will be working in infrastructure, etc., where you'll have servers running at kind of half capacity, ready to run up when something important happens, or you'll have VMs that are just sitting there dormant. And that has a purpose, a business case, but we really need to start asking ourselves, what is the relevance of that? How can we increase that utilization? And if you look at the graph there, you can quite clearly see the relationship between power and utilization is not proportional. So we've got let's take a laptop or a server down there. When the utilization is at 0%, it's still using power. It's in an idle state. It's sitting there dormant, but it's still consuming power. Just because it's turned on, it's still drawing it. However, as we push up that utilization, you can see it's not proportional. So at 50%, we're using a little bit more power, 180 watts, for example, and then we smash it all the way up to 100%. We see a little increase in power usage. So we need to be thinking about how we're leveraging and how we're relying on our systems, our solutions, our servers to really balance that utilization rate and understand that perhaps 50% to 100% utilization is not linear. We need to understand where we sit on that kind of that scale and how do we take advantage of that. So by now we've understood that kind of the idea of carbon extracting value, and we've understood that we want to get as much value out of that first gram of carbon. We've understood the point around driving utilization, so maximizing as much kind of capacity, really pushing out the workload. But what else? Well, this is where a second principle comes in. This is the idea around carbon awareness. And as you look at this very confusing graph on the right-hand side, which I'm going to explain, I'm just going to have a sip of water. So carbon awareness is the idea of doing more when more energy comes from low carbon sources and doing less when more energy comes from high carbon sources. So we just spoke about clean, green, renewable, and fossil fuels. So we want to do more when our energy is coming from some of those cleaner supply chains. We want to do less. We want to do less utilization or less work or whatever it happens to be when it's coming from those dirtier routes like the fossil fuels, the coals, etc. And we call that carbon intensity. So this is how much carbon is being emitted per kilowatt hour. So if we look on that graph, the gram of CO2, so
Looks like we lost sound again. I've got to check it out.
Apologies, for some reason I keep being muted. I'm back.
Yeah, we can hear.
Great. Okay, please do jump in. Apologies for this, everyone. So, of course, yeah, what we're saying here is if the carbon intensity is how much carbon is emitted per kilowatt hour, and as you can see on the graph, the gram CO2 / kilowatt hour. So this is what we're talking about. Imagine if you could then plug your laptop into a wind farm. Well, then its electricity would have a carbon intensity of 0, but that would suggest there's no carbon at all, and none of us can physically pick up our laptop and plug it into a wind farm. So that scenario is never going to happen. It's not possible. Devices, servers, they all have a carbon intensity. And that carbon intensity will be a mix of the current power sources in the grid, both the lower end and the higher end in terms of the carbon intensity. So our winds, our kind of solar have a low carbon intensity, and our kind of coals, our oils have a high carbon intensity. And it does, unfortunately, get a bit more complicated because carbon intensity changes over time due to variability of renewable energy. So you can see on the graph, if the wind stops blowing due to unpredictable weather conditions, well, then we're clearly not going to have enough wind energy. So we're going to have to top that up perhaps with some more coal energy. So saying that we have a server here with a carbon intensity of X might be the case now, but if it suddenly stops, the wind stops blowing and we have to factor in electricity from somewhere else, then our carbon intensity also changes. Now, some of you are thinking, well, Chris, there's nothing we can do about that. Well, no, that's not the case. There is. And the next few slides are going to tell you some of the techniques we can start to build into. And in fact, some of the world's biggest organizations are already building into their solutions to really take into account. So this means that carbon intensity is variable, changes on time and location, of course, driven by the weather. So irrespective of whether or not you've really delivered on your utilization goals, you've built the best piece of green software. And I'll be showing some examples, some code examples later on around how you can build better green software as well. There's still a lot more work for us to do. But if we can start to all think about those millions of engineers and developers, start to really think about leveraging and using more low carbon intensity solutions, and if we start to make that kind of embedded into our software, and I'm going to tell you how in a second, then that means that as an industry, as countries, nationally, internationally, we're going to start to invest in more of these cleaner solutions because the software, the devices, the solutions we're using are only using it at the time and the location when it's coming from those clean areas. So this idea of shifting, if you like, the shifting of where we get that energy from can be split into 2 strands. You can see those on screen. Being carbon aware means responding to shifts in carbon intensity by increasing or decreasing your demand. And we do this through 2 ways. So spatial shifting and temporal demand shifting. I promised you there was going to be another crazy name, and this is it here. And I'm going to go into these in detail, but spatial shifting, you can see, is moving your computation to another physical location. And then temporal demand is actually shifting to another time zone. So let's take a little second and jump into each of these. But what is important before we go on to the next slide is that these actual mechanisms, and I get so excited about this because they're in use already, have been shown in studies to reduce carbon reduction by 45% all the way up to 99%, depending on the type of renewables that are powering the grid at that time. So let's jump into the first one. So this is spatial shifting. This is the idea that moving your computation to another physical location where the current carbon intensity is lower. So it could be the region that naturally has lower carbon sources of energy, for example, moving to a different hemisphere. So on the graph, on the picture, very, very simple. You're seeing we've shifted a data center, perhaps that was in the US using oil. This is purely just for illustration. We've then shifted it over to Spain to use a solar renewable energy supply, for example. But this isn't always possible because if we think around the challenges, particularly around data and security and governance, then we have to think about something called temporal demand shifting. So this idea that we can't always pick up our data center and put it into a geography that has lots of sun because our corporate policies don't allow it. Our client doesn't allow it. Maybe the software we're building or the solutions we're working on don't allow it. So then we move to our second stream that they're very excitingly named temporal demand shifting. And this is the option really that you have to shift to another time. So this is about looking perhaps later in the day or when it's sunnier or when it's windier, and therefore the carbon intensity is lower. So let's take the dream scenario. I'm currently in the United Kingdom. It's grey and it's raining here. But let's imagine I was in Madrid. The sun is shining. I can get all of my nice energy from solar. And on that basis, what I want to do is I want to shift all of my operations, all of my processing, my workload to that sunny location. What we can see here is on the graph, and the time zone at the bottom is overnight here, is that just by shifting 1 hour, all of our workload. So let's imagine a system that's got lots of cron jobs running at night, for example, or updating a database, whatever it happens to be. Let's imagine that we're able to just shift that processing time by 1 hour. We can immediately see the dip in the carbon intensity, because what's happening is during the day, there's lots and lots of demand on the grid for energy. There's loads of demand for energy. So we're having to top up with lots of oil and fossil fuels, for example. But as the evening goes on, people stop watching Netflix, people stop cooking, they all go to bed, etc. At that time, it's the perfect opportunity for some of these massive enterprise systems to start to say, actually, there's less carbon being demanded, so there's less energy being demanded. The solution is carbon aware, if you like. It knows when the carbon intensity is high. So what we're going to do is we're going to shift an hour ahead, and we're going to start to use the energy at this time in the morning when there's no demand on the grid. So we're getting it all purely from kind of saved or reserves of, I don't know, green or renewable energy. Now, let me give you an application. Microsoft have actually released this within their Windows Update feature. So those Windows users amongst you, what they've done is they've actually built in a feature, and I think it's in testing at the moment, but working with the Green Software Foundation, you can check it out. There's some articles out there that users can schedule when they want system updates to happen on their device, not just like they can do normally now or later, specifically when that device shows them a time based on their local energy grid that it's pulling more energy from renewable energy sources than traditionally harmful ones. So Microsoft have built in the capability to use some open source platforms, etc., to say this user is in Italy, this user is in Oregon, or wherever they are in the world, and at this specific time, electricity in that region is being generated by wind, and therefore this high intensity energy demanding update cycle we're going to leverage at that time to use that. And that's the kind of software, that's the kind of green software, that carbon aware software that we should be building into our solutions to actually take that onus away from the user to think, oh, when should I update this or when should I turn this off, and actually empower the software to be carbon aware in itself. And because there is a lot of predictability, we have great weather forecasting metrics, we have lots of tools out there that can provide reassurances around when it is going to be sunny, when it's not going to be sunny, we can actually start to build tools that we feel confident about from an energy kind of carbon aware perspective. But what if those two things still sound, you're still thinking, Chris, this all sounds a little bit too tricky, I'm still not really sure how to approach this. Well, there is one more approach in the kind of carbon awareness toolkit, if you like, and we call that demand shaping. So a bit more of an accessible name here. This is about shaping your computation to match the existing supply without any geographic or time-based shifting. So what you're doing here is, instead of moving or shifting time or geographies, you're actually changing the solution, the software, the application, whatever it is, to behave and act in a different way. You're shaping it. So if carbon intensity is low, you're going to increase the demand. So you're going to do more in your applications. And if the carbon intensity is high, you're going to decrease demand. You're going to do less in your applications. So what you're going to perhaps say is all of those updates, those really intensive utilization tasks, you're going to do those when carbon intensity is low, because you can use nice renewables. But when you're just doing some kind of word processing, whatever it happens to be, you don't need necessarily much going on. You'll do the kind of the lower intensity tasks there. And demand shaping for carbon aware applications, therefore, is all about the supply of carbon. It's about having your tools understand where that carbon's coming from and then shaping the demand to match the supply. And this then enables you to escape some of those challenges around governance and data security, because you're not actually doing any geographic location shifting. You're actually just making a very intelligent piece of software that is able to shift its own computational skills, run its jobs when needs be, check out what it wants to do based on the carbon intensity. And as engineers, therefore, what we should be thinking about is actually in these solutions, these tools that we build, where perhaps we, by habit, say, okay, well, we'll do all the update jobs at midnight and we'll do this thing at just before the working day at 7 a.m. Instead, we should take a bit more of a sustainability lens and say, do you know what, we should cancel that process actually, because the carbon intensity is super, super high, and we'll use shaping instead of shifting to move those activities to a much more responsible kind of time in the day. And that's it. That's carbon awareness, if you like. It's the big one, but it has so much potential for building responsible, sustainable applications that actually, as individuals, this idea about being able to build a tool that's carbon aware, almost giving it a bit of a personality, I think has such an exciting opportunity. So there is 3 principles, as I mentioned, and we're going to move on to the third one, which is hardware efficiency. And it's only one slide, but it's important to mention it. Some of you might be thinking, Chris, you're getting carried away here, but this one's actually overlooked. This is the idea that using the least amount of embodied carbon. So you might be sitting there on your laptop thinking, I'm trying to build a green piece of software here, but you need to remember that the laptop that you're using it on has used carbon to get there. Embodied carbon, as difficult as it is to say, is the amount of carbon pollution emitted during the creation and ultimately the disposal of a device. So when we calculate an application's kind of total carbon pollution or emissions, we should also, in the grand scheme of things, consider, particularly at the enterprise level, the carbon that's embodied through running the solution. So things like its creation and its disposal. Those of you working in networks or architecture or infrastructure probably are always thinking about extending the lifetime of servers or devices. Well, by doing that, what you can actually start to do is spread that carbon, that embodied carbon, across multiple years, and then overall reduce your kind of carbon count. And we call that amortization, but we're not going to talk about that today. There's lots of information on the Green Software Foundation for that. Bold statement. Using cloud computing as well does have the possibility to demonstrate significant efficiencies than on-premise, and many of you will understand that, because actually you can apply demand shifting as well as demand shaping to both of it and actually start to get a really nice wraparound kind of green, aware, sustainable solution. So cloud does have lots of exciting potential, but the Green Software Foundation's key message is about reducing. So things like offsetting and tokens and all of that doesn't fall into the scope of this. I know a lot of organizations get excited about cloud because they can push their data centers to another geography. And that's not what this is about. This is about being intelligent, building great solutions that are able to take on board some of these principles. So there are 2 approaches to hardware efficiency. As a final summary on this, for end user devices, it's about expanding the lifespan of the hardware. And for cloud computing, it's about increasing the utilization. And that's it, really. There are 3 principles. So as a reminder, we've touched on energy efficiency, using the least amount of electricity possible, carbon awareness, doing more when electricity is clean, and hopefully you've got some exciting ideas about some of the solutions you're using that you might be able to think about in that space. And then hardware efficiency, a little bit more challenging, but actually still part of the conversation we'll be thinking about. I am aware that I also wanted to give you some more kind of hands-on practices that aren't necessarily about designing and building carbon aware applications, but instead are what we call practices, not principles, that you can start to consider in your development. So we've got 3 slides, and these are software development practices. And I'm going to put my hands up. I didn't write these. These are sourced from the open source community. I'm certainly not an expert in this space. But this is just to give you a nice feel for kind of practices that are out there that are available for you to be using in your day-to-day. And there's loads of these available on that website, patterns.greensoftware.foundation. It's about 50 plus of these from experts in the space as to how you can actually start to build and change the software you're building to be more sustainable and aware. So there's a lot of content on the slides, a few bullets to read. The green one is the key impact. So first example is around a green software pattern around compressing transmitted data. So some of these will sound very, very simple to some of you, and I tried to pick a selection. But by compressing transmitted data, we're thinking about how do we reduce emissions? How do we get the most value out of that gram of carbon? Well, from an energy efficiency perspective, if we minimize the size of the data transmitted so that less energy is required, because we're then reducing the network traffic, then we can definitely say that we're reducing the total electricity required, and therefore we are reducing the carbon emitted. So some of you might be thinking, well, this all sounds very kind of stepping stone and connected, but these simple practices, these ways of working about saying, if we can think about compressing the data before we fire it over to the client side or before we lock it up onto the FTP or whatever it happens to be, if we can start to think about compressing that data, then there is a positive effect in terms of sustainability. There are some caveats, as I mentioned. For example, you'll see there will be a slight increase in location-based marginal carbon emissions due to compressing and decompressing at different locations, because I know many of the architects listening in always like to throw some challenges back, and I think that's how these things get better. So absolutely, these things are not 100% kind of incredible to celebrate. There are challenges, and there will be offsets as well and challenges that need to be presented. But practices such as this, patterns such as compressing transmitted data, is one of the ideas that the Green Software Foundation is exploring, and the positive energy benefit that comes to it. Our next, a little bit more kind of exciting and less kind of data focused, is around stateless design. So removing state from your design to reduce that kind of in-memory or on-disk data that's being used by the workload to function. Therefore, we'll need smaller computing sizes. So we're thinking about utilization, we're thinking about using the resources available to us. Well, if we are using a virtual machine, for example, as I mentioned at the beginning, we sometimes have lots of VMs just hanging around, aren't necessarily doing anything. Well, if we can increase its utilization, we can therefore increase its energy efficiency, and we know that that's going to then go towards reducing our carbon. So, for example, something like stateless design, where we don't have all of that data sitting there in the memory needing to be called back and consistently kind of backwards and forwards, we can reduce the size of memory that's needed. And then in turn, let's imagine that's in an enterprise level, multiply that by, I don't know, 20,000 engineers, you can see there's considerable changes here. And then our final one is around tracking only necessary data. I think perhaps many of us are no doubt guilty of this. We try and build in as many kind of tracking points, touch points. We want to see as much data as possible. But let's think about actually, if we avoid tracking so much data, we avoid all of those calls, all of those kind of requirements to push things, download touch points, etc., then of course we're reducing the computation, and we can therefore reduce the amount of energy consumed. So that's it. We've kind of gone into green software, we've gone into principles around energy, we've gone on to hardware efficiency as well, although it wasn't necessarily the scope. And we spent a large portion of this talking about carbon aware applications, which I think is the most potential. I've got three kind of touch points, or three kind of things to pick up here. So one, please do start to think about applying these strategies into your design plans and ongoing development. Start to have these conversations with your team, maybe even refactor some code to think about when you're executing jobs, or think about the geography you're in. Two, definitely check out some of those practices. You're all going to be far more expertise than me in this. There's about 50 plus practices covering everything from AI, cloud, Kubernetes, image rendering, etc. on the Green Software website. And they welcome contributions from the community as well. So you might have some fantastic ideas. You can submit them and get those checked out. And then finally, secret insider knowledge. There's actually a free certification from the Linux Foundation, the Green Software certification. And a lot of the content is really what we've been speaking about today. So if you like, if you didn't get anything else from this, take this as a kind of 40-minute private tutoring, if you like, on the Green Software certification. There's a lot more information on there, a lot more to learn, but it's actually for all practitioners. It's not engineering heavy, analysts, consultants, QAs, UX, whatever. The Green Software Foundation certification is available and free through the Linux Foundation. So please do check that out. And that brings me to the end. There's my Twitter if you want to check out what I'm doing in the open source space. I'd love to talk about open source and sustainability, but we'll save that one for another day. And I think we're going to go into questions now. So over to you, Sergey, I believe.
Now we have questions. So, and the first question is, in IT, how carbon awareness and carbon efficiency is currently measured? Can we measure that carbon in our IT industry, and how?
Yeah, it's a great question. And actually, I purposely didn't reference measurement at all in my talk, because I think we could talk about this for a very long time. There are various tools out there. I think you only need to go to GitHub and type in kind of carbon measure, carbon tooling, whatever, and you'll get loads of kind of indexes out there. But of course, I'm going to wave the flag for the Green Software Foundation. They've built something called the Software Carbon Intensity Index. And it's a formula which actually you can apply using a number of factors, so energy, intensity, where that energy is coming from, lots of stuff we spoke about today. And at the end of it, you get a score. And at the end of it, you get a kind of index, a point as to what that piece of software, that unit of work, could be a job, could be a web page or opening an app, and you get a score. And then you can apply some of these practices, these principles, and then execute that index again and see what impact you've had. And in some cases, I'll be super transparent, you don't see any change. And you actually think, well, there's no point us executing this piece of work because it doesn't have a positive impact on the carbon. Of course, in other cases, you do see a saving, and then you can start to roll that out across it. But there are loads and loads of measurement tools out there. Some organizations are building their own. I think that's fantastic. But in the spirit of open source, I'd love to see more people leveraging things like GSF's index and then building and contribute back onto that.
Yeah. Cool. Well, actually, I think maybe in the near future, some laws will may be passed to control this. So we need real measurement of that. So to comply with the with that green laws.
Absolutely. I mean, again, another area we could talk about is around kind of the protocols, the kind of greenhouse gas protocols, the scope 1, 2, and 3 emissions that many people will have heard about, and how globally emissions are tracked and where those emissions are coming from. There are, absolutely, as you say, there are already companies that are building into their procurement policies kind of caveats that say we will only engage with organizations that are able to demonstrate X, Y, and Z. And similarly, like you say, there are definitely laws. We only have to think about things like the COP summits and the various Paris agreements, etc., that are now mandating that certain organizations are able to demonstrate usage of X, Y, Z in terms of their own energy. And I think that's why this is exciting for the development space, is that as engineers, we're kind of on the precipice, the cliff edge of being really hands-on with this. We could be the people that turn around and say, we've built a solution that is carbon aware, that it already takes into account all of these factors. And from there, we're now able to kind of wave our flag for our organization and say we are really championing the sustainability conversation.
Well, maybe governments, if they're interested, can go further. Maybe they can give some tax preferences for that. So if you're green, you have your tax preference, you know.
Yeah, I mean, absolutely. I mean, maybe not, maybe even individuals. It'd be fantastic if we could all demonstrate through our own recycling and reuse that we perhaps got a tax break. But yeah, absolutely. I think there are loads of incentives out there. I mean, tax breaks would sound like a fantastic idea.
Yep. And we have another question. Does compression not decrease carbon efficiency by using more CPU power?
Absolutely. So this is exactly the point that I think is so important, that a lot of these practices have assumptions and caveats in them. So if you are compressing, of course, you're increasing utilization on your device. And by increasing utilization, you're demonstrating efficiency, but at the same time, you're demanding more energy. So then what you need to think about is, and this is where it can get a bit blue sky, is you could then say, well, I'm only going to do my data compression in the evening when I know that carbon intensity is low, and therefore I'm going to be using wind power only. And then once I've done that compression, I'm going to then upload it or fire it across to whichever geography it needs to be at this time, or when we're using a data center in another location. So absolutely right. It will have a positive and a negative, but what you have to do is you have to work out what that net is and then make a decision. And you could get carried away with this, and I'm sure there are loads of people out there that would start to think, well, we could do X, Y, Z, and then you might end up with a process that takes 36 hours to execute, which is not ideal for anyone. But similarly, think about the kind of data you're compressing. Are we talking kind of terabytes, etc., or are we talking a few images on a website going between kind of corporate devices? It's about kind of understanding where we sit in the enterprise level. But that's a super valid point, and perhaps demonstrates it better than my slide around the positives, but also the negatives, or the kind of thinking points that have to come apart, that a kind of realistic lens when you look at this.
Yeah. And by the way, do you maybe have any idea about how our cloud providers, are they in that green competition? Do they make their data centers green, or maybe they have a green index? Which cloud provider is greener than other?
Yeah, so there's two answers to this. So from a supply side, so for the people that are using cloud, and perhaps many of you have got your own kind of Google Clouds or AWS that you're
Mhm.
logging into, there are features within those tools, fantastic features that show you where your data center energy or is kind of being sourced from. And I think you can go in, you can look at how much carbon you've emitted through your operations. You can actually say, I want you to execute from this region, because perhaps you've got your own prior knowledge. In fact, even some of the suppliers have a little green leaf next to the graphs that say this is coming from a renewable data center. On the other side, there are, of course, green data centers, we call them, or data centers that are geographically kind of located closer to where operations are happening. There's lots of stuff going on around sustainability in data centers and how we can reduce overall energy consumption. But what I think is really exciting is actually, as individuals, we know we've got the tools, we've got the processes to actually empower ourselves to go beyond having to rely upon a third party to tell us that our energy is coming from a green data center. We've now just seen in that kind of last 40 minutes that there are tools out there that will enable you already to start to think about your own solutions. So perhaps take the onus off the supplier and start to actually build it and embed it into your own software. And then you can be almost certain that you're using kind of realistic, sustainable kind of renewable sources.
So talking about software, well, people are asking, isn't in oh, should we now stop using like Python as it probably is considered the most energy consuming programming language? Well, I personally thought it was Java actually. Well, but what about the programming languages? Right.
Yeah, this is how you immediately make friends or lose friends. So I'm absolutely not not going to play that game. What I am going to say is that Rust, for example, is actually seen very, very positively in the sustainability space. So there's been lots of exciting kind of studies into the computation required to process and kind of render and do what it needs to from that coding language. But similarly, and I think rightly so, there's also been some criticisms around the models that are used to actually compare things like Python to Rust, Java, etc. There's an offshoot that I want to mention, which is around open source and around open source languages, of course. I mean, some of the biggest languages in use are Python, JavaScript, and I think we have to take a sensible hand to say we shouldn't necessarily be saying one language or the other is better. We should be thinking about how we're using those languages to build solutions. So it's not the in this case, it's not the tools, it's the end product, which I think is the important point here.
And I see a question people are asking, are there any best practices to encourage more and more users to use software systems in a more energy efficient way?
Yes, there are. I mean, I think the cheating answer would be that we should all feel compelled to do it, because I think we all care for the planet and we should all be kind of encouraged to do that. But there are organizations that are really getting behind it and kind of providing benefits and recognition to those organizations, to those individuals that are. In terms of practices, principles, or ways of working, I mean, I am going to mention the Green Software Foundation once more. They have an amazing repository on GitHub, which is not their tools, but it's an entire list of anything you can imagine in the tech space, but they're all sustainable. So if you're looking for something to do with CMS or images or something to do with even culture, writing strategy documents or product visions, there's an entire bank of sustainable frameworks, ways of working, practices that aren't theirs, that are crowdsourced, brought from the community, that are very, very kind of easy to digest, very, very easy to access, not super complicated. I know today we mentioned lots of things like temporal demand shifting. I promise you there's none of those words, but there's loads and loads of frameworks and models out there. And the Green Software Foundation has a great repo that lists all of those under the title Awesome Green Software.
Well, I'm just wondering, what can we do now to cryptocurrency and miners?
Yeah, good question, and I'm gonna add AI to that as well. I think we're on this. 2-3 years ago, we were talking about the environmental damage of the blockchain, et cetera, et cetera. Now we're realizing how data intensive AI and large language learning models are, and I think we're not going to be able to escape that. We're not going to be able to mitigate that. What we are going to be able to do, though, is unlike where we were with blockchain, where perhaps maybe some of you will disagree, we were perhaps caught out with the blockchain kind of emergence from a sustainability perspective. It happened, and then we realized. With AI and LLM, we can't be naive and say we're not aware of this. We already know the demand, the intensity that these operations will have from an energy perspective. So we should, from day one or day zero, be embedding and building in these practices, these principles, these ways of working to make sure that we don't have the equivalent of a kind of mining operations with hundreds of servers doing the same for these kind of large language AI models, which are very, very powerful and beneficial, but at the same time can very much expedite that kind of negative carbon trajectory that we're on.
And besides miners, we have a great number of gamers, and the gaming industry is huge, and the guys are playing day and night, and lots of them, by the way. So how can we affect them? How can, how can we make them stay green, or can anything be done with that gaming industry? And
I think it can, and I think it's probably a simple answer. It goes back to the data center conversation. So if we think of some of the biggest kind of online games that are out there, you can pick regions where your servers are. You can say you want to play for X on X server or X location. You can even have in your settings kind of configurations to say when you are playing and where you're playing, etc. I think that they, as organizations, can perhaps start to build into their own software kind of mechanisms to kind of attribute users to like low carbon intensity. So maybe you suddenly see a reduction in the quality of the players because you suddenly jumped over to a country that perhaps doesn't have as many good gamers. And I'm not making any statements here, but you could just feel confident that you're aware that you're using sustainable energy. Similarly, I think what's interesting and exciting is a lot of these games obviously rely upon massive amount of data in terms of just to get them to operate. So if we take things like the Unreal Engine, which is obviously used across a number of gaming platforms, the data that's physically required to execute that and the downloads to local machines, perhaps they could start to explore and mirror things like we saw with the Microsoft Update Initiative to actually say, well, we'll only push these updates. We won't push them at the point of initiation on the device and say, you cannot play until this has happened. What we might say is that at 7 p.m. tonight in your region, you're going to be using solar energy or whatever it happens to be. So we're going to push the update then. And I think if you measured that, extrapolated that across the millions and millions of gamers, you could definitely see a positive impact. Absolutely.
I agree. And there's an interesting question. And the question is, when silicon-based calculation would be more power efficient than protein-based calculation, that is, calculations in a human brain, so would it mean that it would be end of protein-based life on the planet?
Wow, okay. I think I need another coffee for this one. I'm going to take that as a thinking point as opposed to a question, Sergey. But yeah, absolutely, it's a very good point.
All right, let's take a look at another question. Well, isn't in general enhancing application performance will eventually lead to less energy? So I think the answer is obvious, yes.
Yeah, I mean, we could have just got rid of my 36 slides and just had that on slide number 1, and I think we'd all get the message. Absolutely, it is. If you can increase performance, you can increase efficiency, you can maximize utilization. You go back to that very foundation stone, which is around carbon efficiency, and it's about getting the absolute utmost value from the gram of carbon that's emitted. So not just doing a quick fix, building a kind of hacky solution that does what it does and executes when it needs to in X geography, and instead making it carbon aware, spending a little bit more time, using a little bit more computational power to spend some time, both protein and silicone based, and then having a solution that's far more responsive, sustainable. Absolutely, it's going to reduce carbon, it's going to reduce emissions, and it's going to make you a far greener piece of software.
Well, and the last question, not even a question, but maybe you can give us some good advice, what we can do in our homes to make our world greener. We have lots of gadgets, computers, laptops, whatever we have. Yeah. What is your advice for us?
Yeah, my 2 pieces of advice, because I had a feeling this question might come up, is 1, think about what we just said around the idle state. So the idea that when something is in an idle state, and that could be as trivial as your TV in standby, or it could be the fact that you've had a very busy day working, you've left all your windows open on your laptop or your Mac, you've closed it and gone to sleep for 12 hours. The impact of that's still using zero utilization, but 50% of its energy, etc. So that's a very important point. And the second one is actually, if you have got smart devices, particularly some of the latest smart devices, take 5 minutes and just type in energy or sustainability on that device and see what options come up to you. You'll be super surprised. So things like nighttime mode, reactive screen brightness monitoring. You don't need 100% screen brightness when you've got your office electricity lights. Just take 5 minutes and have a look, and all of those little tiny things will have a massive positive impact. And if you are, fine, I'm going to take a final 30 seconds. If you're someone who's actually responsible for building some of those solutions, then start to look at what competitors, clients, other people are doing in that space and borrow those ideas in the spirit of open source to start to build them into your solutions as well.
Well, unfortunately, guys, we're running out of time, and I would like to thank you, Chris, for sharing your experience and insights with us, and I would like to thank our audience for their engaging questions.
Thank you so much.
And let's then now jump right in our next talk, AI-assisted engineering and more, where we will explore how AI can change the way we approach engineering and solve problems. Prepare to be amazed by the world of AI and engineering. I am Sergey Konstantinov. We'll be right back after the commercial break. Stay tuned.